Hello everyone. Things are a little bit different today. First of all, I'm on camera, so be nice. Second, I am in my garage. And that's because I have a few things I would like to show and tell. It's been over a year since I did anything with my IBM PC XT build, and that's because I didn't have any floppy drives. I do have a floppy drive controller and a PCB to put it on, but no floppy drives means no PC XT. It took me a while to find some drives, but when I finally did, I got 3 of them. And I got 3 of them because I would like to put one in my IBM PS1 from 1993, and I would like to put one in the PC XT when I get that ready to accept a floppy drive. And third, I would like to put one in an intermediate PC. So I have this old box from about 2004 that I can put one of the floppy drives in and test them out before I do anything wild with them. I can also use that to back up some old CPM floppy disks. And since this thing is completely dead and has been for about 10 years, I'm lucky that my friend from my day job decided to gift me this. This is a motherboard from around 2010, and the cool thing is it has modern connectors for a lot of things. It also has a PCI slot along with a lot of PCIe's, and best of all, it has a floppy drive controller and a port for that, as well as IDE. And that's cool because I can test a lot of the old stuff and use modern things to interface with it. I think I'm going to install a modern Linux on it, and we'll see how that goes. So let's open this up and see if the power supply still works. I'm pretty sure the motherboard is pretty dead in there. My usual strategy for these things is to unplug the motherboard and see if the power supply fan spins before attempting anything else. If everything else looks fine, we can move on to visually inspecting electrolytic capacitors and checking the power rails for shorts. But the motherboard here is absolutely filthy. So even though it might not be a horrible candidate for testing old floppy drives, cleaning it out and getting it running is a job for another day. Of course, I could make it seem like swapping out the motherboard is as simple as, let's say, snapping my fingers, but I have a feeling we might find something interesting inside for later and maybe learn a bit on the way. So let's dig in. If we take a look at this super dusty ATI Radeon 7000 32MB AGP GPU, we'll notice it's only dusty on one side, but also see it has a heatsink on the other side to take care of the maximum 32 watts this beast can put out. I think I saw a leaky cap, but if we change that, it might live again. The only other card in the machine is a dusty PCI Ethernet card, which you're probably not surprised is based on the Realtek 8139. That was super common 20 years ago. Considering the dust seems to have settled by gravity, it looks like this motherboard could have lived longer with a bit of positive case pressure. I guess the single CPU fan just managed to pull in some dust from the outside. With those goodies out of the way, let's see if there's any hope for the hard drive and power supply by flipping it on. If you haven't tried something like this before, the trick is to connect the power supply on wire, which is usually green, to one of the black wires next to it. We won't risk powering it up with the motherboard connected, not just because of the condition it's in, but also because it's 20 years old and it's easier to fix before letting out the magic smoke than after, by changing bulging caps, for instance. I am super happy to hear the hard drive spin up, as I have a feeling there's data on there I'd like saving. And of course that also means the PSU fan spins just fine. I guess we can test the PSU a bit more later. But let's push along and take out the motherboard to make room for the new one. Whoever put together this box didn't waste time putting in too many standoffs for the motherboard, so it's pretty easy to get out. And now we can really see how dusty it is. But at least it looks like it's only dust, and the capacitors on there seem to be in pretty good non-bulgy shape. It really might be fun to fix this up another time. But let's stick with the plan and stick the newer board in there. But luckily I realized the power supply is more compatible with the PC XT than it is with this newer motherboard, since it only has a 20-pin motherboard connector and no extra 4-pin section to be found anywhere. This might be a good time to give it a quick clean, so I give it a few passes with the old sucker and leave it at that. Well, I guess the good news is we don't have to rely on a 20-year-old power supply with no SATA power connectors either. Bad news is I'll have to find a different PSU somewhere. Now let's grab the power supply and take a look at it. It looks like a pretty generic 300 watt power supply, and even though it might not work for what I have in mind right now, it might be pretty good for another retro build since it has a negative 5 volt rail you won't find on modern PSUs. Like the 500 watt Cooler Master I luckily have ready to finish the build. I probably could have found another older used PSU that could do the trick, but I don't mind using this one for the build either. I'm trying to install the board with the case vertical for the camera, which is not something I can recommend, as gravity is not being very cooperative. The fact that the screwdriver I have here is mostly demagnetized doesn't help either, but at least there's a way to fix that part. Since there's no onboard graphics on the motherboard, I'll also have to sacrifice this Sapphire Radeon R5 230 card, which should do just fine. We won't be gaming any modern games on this anyway, and it's got both VGA and HDMI, which is perfect. I guess that's all we need to test if it works, so let's give it a go. Of course, I didn't hook up the front panel connectors yet, so I think I'll just stick with plugging in the power button for now, as I just can't wait any longer to see what works. Time to press the button. And besides the cable hitting the fan, it actually sounds like something good is happening. Looks like we have a 2.6 GHz i7 and 16 gigs of memory. And it detects the IDE hard drive as a Hitachi drive. Let's see what it does if we let it try to boot. Of course, it's very unlikely it actually boots with a completely different motherboard and graphics card, since I remember nothing really worked back then without the right drivers. I'm a bit surprised it actually got this far and hasn't even complained yet. And that looks like a Windows XP progress bar. Oh wow. That was so short, I'm afraid the camera didn't catch it, but I'm sure I just saw the Windows XP boot screen. But now it rebooted. My guess would be it's not super happy with the GPU or motherboard, but it was fun it got this far. I'll give it another go in safe mode, but I doubt that'll do much. I also tried to disable some modern features in the BIOS, but at this point my camera ran out of juice and I was too busy playing with my new old toy to notice. Whoops. Off camera, I did try making a DOS 6.0 boot disk with the PS1, but since that can't read the NTFS formatted Windows XP hard drive, that didn't do much either. And of course, I don't even have the 5¼ inch drive in there yet, so let's get everything plugged in and install us some Linux. Getting the front cover out of the way isn't a problem, but it seems the metal covers underneath are simply designed to be removed by violence. I want to install the drive in the lower bay to make sure the cables can reach the connectors, but that won't work if I want any of the RAM slots populated. so I guess it'll have to buddy with the CD-ROM drive. No problem, that just means we have to move up the hard drive since the only 4-pin power connectors are on the same cable. That also gives us a chance to take a look at the labels of the floppy drive and hard drive. The floppy drive we have here is a common Alps Electric 3.5-inch drive from week 28 of 2004, and it seems to work great, so it's going right back in there, in a different spot though. The hard drive is indeed a pretty dusty Hitachi 40GB drive from September of 2004, so I'll give that a wipe before putting it back. The floppy cable I have isn't quite long enough to reach both drives, but I think I have a way around that. But for now, I just want to see if I can boot into DOS and access both floppy drives, so I'll just leave the 3.5-inch drive hanging there. For some strange reason, I can't seem to get it to boot from drive B no matter what I do. So to boot from the 3.5-inch drive, I would need to plug in the 5.25-inch drive before the twist in the cable, which is nuts. Something weird must be going on. But now I really can't wait any longer to see if we can read some 5.25-inch floppies, so I'll just leave that plugged in without the 3.5-inch drive connected and boot Ubuntu Linux 2404 from a USB stick. With Ubuntu booted up, we can just quit the installation for now and take a look at what we have. The floppy drive reacts when I try accessing it, so that's a good sign. Let's see if we can actually read a floppy. These floppies probably haven't been written for over 30 years, so I wouldn't be surprised if we can't read them at all. But here we seem to have a backup file. And if I'm not mistaken, that's exactly what's written on the floppy itself. Yay! I'll try to back up this backup later, but for now, let's have a look at the 40GB hard drive. And it turns out it actually has some old personal data of mine in pretty good shape. But I'll try not to overshare for now. I'd like to get both floppy drives connected before I close up the case, and I don't have another longer 34-pin cable, so I'll try something else. Last year I got a few of these adapter PCBs that turn 3.5-inch connectors into board edge connectors, links to the design files in the description, and it looks like they come in handy now as the board edge connector near the 3.5-inch drive looks like it'll reach. With that connected, I'll also plug in a SATA hard drive we can install Ubuntu on and hopefully use to back up the 40GB drive and all the floppies. Let's close it up and run the install. If you've ever held off trying Linux because it's complicated, I'm sure you'll see that's not the case, as it's mostly just clicking next. I do partition the drive myself, which I don't really have to, but I split the drive into a 100GB system partition and a larger home partition for user accounts, since that means I can reuse it if I decide to install a different Linux distribution later. Linux also likes a swap partition sometimes, so I create an 8GB swap partition. The swap partition kicks in if you ever run out of RAM. And now we just let the install do its thing. After a quick reboot, I think the first thing to do is back up the 40GB drive, so let's put a clone of that on the big disk. You might worry I'm going to open a terminal and start writing complicated commands, but actually it's as simple as opening disks, clicking the disk and selecting Create Disk Image and a location to put it in. Super easy. After a few minutes, we have a 40GB file on the hard drive and my precious data from the early 2000s is safe once again. Luckily, the disk is in good condition, so we didn't have to try anything hard to get the data off it. But we might not be so lucky with the floppies. Since the floppies do seem to be formatted as standard IBM 1.2 megabyte floppies, we can try the same thing, and if we run into trouble, we can try something else like DD Rescue or Dave Dunfield's image disk in DOS. The next part comes with a bit of hindsight, as I made a mistake I didn't catch until I already tried everything, even though I should have caught it right away. Maybe you'll catch it too. I used the same backup 11 disk that seemed to mount and could list files before, but for some reason it does not sound like a happy camper when I try to image the disk. Have a short listen. Since that sounded like a horribly broken disk, and I missed the solution that was staring me right in the face, I went straight over to download DD Rescue and tried to recover as much data as possible. DD Rescue has a lot of options, but even if you're not an expert, you can simply use DD Rescue, input file, output file, where the input file in this case is the floppy drive. I was expecting DD Rescue to at least recover some of the data, but that too sounded like it was chewing the disk rather than reading it. So I decided to try feeding it another disk, and that didn't sound much better. I don't actually have DOS installed on the machine, but I have DOS on a mem disk along with Dave Dunfield's image disk that I can boot and test the drive and disk. Later I will probably replace the 40GB drive with another one with a master boot record partitioning scheme and boot DOS or Windows from that. Now the funny thing is, image disk reads the floppy perfectly because it basically has its own floppy driver and talks to the floppy drive controller directly. That also means that when I use image disk to clone the disk, we actually get a file we can read using the image disk viewer program. It looks like a good old DOS 3.3 backup with some WordPerfect files. Cool stuff, not super interesting. If you'd like me to go into more detail with image disk and how it works, feel free to tell me in a comment or over on Discord. But if you'd like to hear more from someone else that knows more about it, I suggest you check out Adrian's Digital Basement. So what was the problem? It was the BIOS. I should have caught it when disks reported the failed image as 1.5 megabytes when it should have only been 1.2. The BIOS was configured for a 3.5-inch drive. I think I was trying to test if Linux could still detect the drive like image disk does, but completely forgot about it and went down the rabbit hole of trying to recover perfectly fine data. So after changing the drive type in the BIOS, I can read the same disk using disks with no trouble whatsoever. And hopefully I can read most of these disks that way. In Linux, I could also change the drive type using fdutils, which includes a program to change the drive parameters and ignore what the BIOS is configured for. And I'm going to need that later because I also figured out why I couldn't get both drives working at the same time. You see, it's a feature, not a bug. Hidden away in the motherboard specifications, we see it has an IT8720 chip that has one floppy disk drive connector supporting up to one floppy disk drive. So of course when I saw that, I got a little bit sad to see the motherboard doesn't actually support two floppy drives. But then I asked myself, why? I grabbed the datasheet for the IT8720F Super I/O chip and sure enough, it does have control signals for two floppy drives. So actually, the floppy drive controller does support two drives, but most likely, and I'm guessing here, Gigabyte decided it was more important to use those pins for thermal status communication with the CPU than a second floppy drive. I guess some people like to know the temperature of their CPU. So why am I ranting about this? Well, because I'm not giving up here. If the motherboard doesn't support 2 floppy drives, I think it's time we make it. I know it's pretty far into the video to present a cool hack, but I'll let that be a reward for those who stuck around. Thank you. You see, the only difference between floppy drive A and B on an IBM compatible computer is this little twist on the cable which swaps the drive select and motor enable signals from B to A and A to B. So you get 2 drives even if they're configured the same. Since the reason we can't use a second floppy drive is that 2 of those pins on the motherboard aren't connected, we only need to find a new way to connect 2 out of the 34 wires to the second floppy drive, as all the other signals are identical. I have to admit, I'm not 100% sure what the best way is to find 2 new wires instead of the ones that aren't hooked up to the motherboard connector, but I know we have quite a few options. First of all, there's a lot of unconnected fan headers on the motherboard that might work somehow, but sadly most 3-pin headers aren't controllable, and I think the tachometer pins are mostly hardwired as inputs. That leaves the PWM signals on the 2 4-pin fan headers, which would leave the CPU fan speed completely fixed. Maybe that's okay for this machine. Second, we could just put a big old switch on the front panel to manually switch the wires around, but that doesn't seem like a very elegant hack to me. Third, there's the front panel connector, which does have some pins we might be able to repurpose. There's the chassis open detection pin, but that's not configurable as an output, so that won't work. Then there's the disk activity LED and the power sleep LED. Hard to say how easy it is to take control of those. Fourth, there's the IDE connector that we currently only have 1 single drive connected to, so we could technically use all 16 bits of the bus as outputs if we connected some registers instead of a second IDE drive. Fifth, we could just connect something that has actual GPIOs to one of the internal USB ports, but maybe that's just too easy. Sixth, we're not even close to running out of options. We also have PCI and PCIe slots. Where there's a will, there's a way, and with enough determination, I'm sure we could install 4 floppy drives if we wanted to, but for now I'm happy with 2. After finding the best way to control 2 wires inside the case somehow, we'll have to modify the kernel floppy driver and use FD-utils to change parameters. That's a bridge we can cross when we get to it, but that won't be today. Eventually, I will get around to soldering the floppy drive controller for my PC XT from scratch build, but we might try hacking this machine to control 2 floppy drives at once first. Please leave a comment if you prefer I start working on the floppy drive controller for the IBM XT, or you'd like to see if we can hack this box into accepting 2 floppy drives at once. I have a few stacks of floppies I need to back up now, and I hope you enjoyed the video. If you'd like to support me and the things I do on this channel, feel free to take a look at the electronics kits and components I sell on my store. Link in the description. Either way, thanks for watching.